Hello, and welcome to our hackweek project, which is about a GPU accelerated generation of contacts between convex rigid bodies and signed distance fields. On the left-hand side here, we have a gray-masked shader view, and on the right-hand side, we have a debug view with a debug geometry. So what we can see here on the left-hand side is that we have an ocean that is defined in a very small shader using a few sine waves, and a rigid body, which is the teapot, that is just any old collider that we can import in Unity and in the physics system. The signed distance fields themselves allow very flexible geometry, both in terms of it allows us to make a shader, which generates the ocean that you can see here, but it also allows us to do constructive solid geometry, which means that we can subtract different geometries from each other, and also we can subtract distance fields from each other. So the big sphere that are rotating this way adds to the geometry, and then you have another sphere that's invisible that rotates the opposite way, that subtracts from the geometry. And this sphere is right now subtracting itself from the ocean, and of course the teapot falls into it. This allows for very dynamic situations and geometry, as well as very rapid prototyping, because we can use this to combine primitives and cut holes in them, and you can cut anything from anything and add anything to anything and find the intersection and so on and so forth. And we can write any shader that also subtracts or adds to anything else. And the only limitation really is that on the right-hand side here, you see that the grid here, it has a resolution. And this is the resolution that the physics runs on, because that is where we actually generate the contacts. So if we just remove the render mesh here, and then we can see the rigid body that is beneath. This is the convex primitive that the physics system actually sees. This is a gift wrapping of the teapot, as you will, and we can gift wrap any object into the system. Yeah, we have all this flexibility, and we don't have to worry about that if we subtract meshes from each other, that we get a degenerated mesh out of it, or the mesh doesn't have the right winding order and so forth. We can very quickly subtract things from each other and get a good result out of it, an always valid result. So it's also worth noting that this all works seamlessly with physics. So if you have any other colliders in the physics system, such as the green boxes in the background here, they are just normal geometry. The context that's generated with the teapot and the rest of the environment, that looks completely the same to physics. So we are free to mix and match anything, and we can add like ray casting support later, and shape sweeping. That's interesting to look at how that can be done. Ray casting is trivial to implement, and the sweeping is a bit more involved. But it can be done. I definitely think it can be done. So what we also can do, just for the lols, is we can take the contacts that we generate, and then we can use them to generate a fake buoyancy force. And this gives us this teapot that is sort of floating a bit on the ocean, and the contacts look a bit like bubbles here. And how this works is that the set of contact points will sort of represent the volume of the fluid that is displaced by the volume of the teapot, and the force of the buoyancy is proportional to the amount of volume displaced by the teapot. So we just basically take all our contacts here, and then we approximate them by a box, and then we use the box to push to add a force for the teapot. And of course, I say that this is all seamless. So let's take the box and generate a few copies of it, and enjoy many teapots that are floating in water. Nice. And there we go. Disable the contacts because, of course, drawing debug geometry is always the bottleneck. And now these are just floating around the ocean and enjoying themselves, and maybe they are waiting for that we use a distance field to generate a whole city, then add water to that city so they can float around in that.